Thanks.
Okay, hello everybody. This is Dr. Patugi, and as you know, as promised, I'm here to solve the sample questions for the final exam. I have shared them on my screen. Of course, the format is like a paper formats exam, but uh, these are the questions that you have seen on Blackboard. Some of you, I noticed that some of you have already answered them, and some of you missed it. That is fine. Sample questions are they're there to help you to kind of get familiarized with the style and the types of the questions for the exam, which for this course, you should have already get exposed to two other previous exams, and the style is going to be the same thing. Anyhow, let's get started. As usual, I have multiple choices here. The first question is about which statement is not correct. And of course, we go over the questions and make sure items and make sure that which one is correct, which one is not. So the part A says authentication works based on user unique information. Of course, this is one of the basic things that we mentioned in the definition of authentication. For authentication, user should have or possess or have in hand something or which is unique for each user. Second item B says a multi-factor authentication is technically a series of cascaded single-factor authentications, which all should go through. Otherwise, the user failed getting access. This is also correct. I mentioned this in the lecture that it's a series of authentications that you need to be able to pass all to get into the system and get access to the resource or get the service. Item C says the process of establishing confidence in user identities that are presented electronically to an information system is called verification. Okay, this is basically the definition of authentication. So up until this word, everything's correct. But here, when it ends this is basically the definition of authentication. So I mark this item to be incorrect. And then last one, it says function and services subject to authentication can be either local or remote, which again is correct. I explained it, but sometimes you log in, you get authenticated in order to open one of your local files. That's the time that you log in your computer, in your laptop. That's a local authentication. And sometimes you log in order to get access to your email, which is a service you're accessing remotely. So item D correct. So please feel free to interrupt me and ask question, Rad, if you have any question. Otherwise, I just keep going forward. I know that this is a exam week and you're gonna be busy with multiple courses, so that's why I don't want to make the recording too long. I want most of you have the time to explore it and take advantage of it. Multiple choice 2. Which of the following statement is not correct? Smart tokens often consist of memory with no processing capabilities. So let me get back to these. Or maybe now I can talk about it. Basically, smart tokens, we define smart tokens, they have memory and they have processing power. We basically define them as a very small, tiny embedded computers. We said that they have I/O, they have um, a tiny processor and a memory so that the processor accesses that memory and runs something. So that is why this statement is incorrect. Computer-generated passwords are not good. We mentioned computer-generated passwords are very strong, but the problem is users have a hard time remembering them. In one of the lectures, I noticed that I used to get access to Wi-Fi of one of my friend, and the password was contained in a file. It was so big, and we basically ended up not being able to use it. Wi-Fi. Anyhow, item C says easily guessable password can be found using reactive password checking method. This is correct. We talked about it. We said that at server side you can run, or at when the user is getting getting registered, we can run reactive password checking and find them and ask the user to change the password. Item D, authentication using memory card is vulnerable to physical loss of the token or the card, which makes sense and it's correct. If I'm getting authenticated using a card, so now the situation is that I have to keep that card secure. Otherwise, if anyone accesses that card, can use that card and get into the system. So correct. Multiple choice 3. Which of the following statement is correct? Per mutual exclusiveness of roles in role-based access control model, a user can be assigned to multiple roles at a time. So this is correct. Because in role-based, you can define, I'm sorry, this is incorrect. Because in role-based, you cannot define more than one role at a time. You might have the chance to change the role at some point, but every user should have only one role at a time. So this is not correct. Environmental attributes are used for authentication purposes in both attribute-based and role-based. Of course not. In role-based, we only use roles, and in attribute-based, we use attributes. So that's why this is incorrect. If this one wasn't here, this statement would have been turned into a correct statement. Item C says, although the set of roles in role-based model is supposed to be static, one can implement some levels of dynamism using family-based or change of the roles at some certain point of time. This is correct. This is what I mentioned just here, that roles are supposed to be unique and are supposed to be static, but you can change them at some point. And then your system continues with the updated roles. So this statement C is correct. And item D says the complexity of discretion access control model with n users and m resources is O of m divided by n. This is incorrect. It's basically complexity of this is the correct answer. If I wanna, I guess I'm not able to write here. The complexity is O of m times n, not O of m divided by n. That's why this one is incorrect. And the answer to this question is item C. Any questions so far? So multiple question 4. Which of the following statement is incorrect? State-sponsored intruders are often those who conduct advanced persistent threats or advanced persistent attacks. Yeah, we discussed this. State-sponsored, basically, it makes sense if someone is persisting and is repeating an attack and trying it in many different ways, that means that this is their business and someone is supporting them financially. And in cases, or in many cases, they might be sponsored by a state. So this makes sense. This is correct and not the answer of this question. After an intruder accomplishes their attack, they do their best to remove signs of their presence. This is correct. We mentioned that they don't want to give any sign or reflection that they were there until the time that they're done with the intrusion and they're sure that everything they wanted to do is done, all files and databases they wanted to remove or they wanted to copy are done. Now that's the time that they post something or do something so that the network administrator people, they get information alerts, or they've been notified that, okay, someone is here. Item C says a low interaction honeypot is less costly as it implements not all layers of the service. This is again correct. Low interaction honeypot is a honeypot that only interacts few low layers of the network. It doesn't, for example, it accepts a TCP connection or a UDP connection, and it reacts the requester like that this is a TCP server. Okay, but it doesn't go to the application layer, or it doesn't interact like an application. Item D says firewalls can fully protect against internal and external attacks. Of course, this is incorrect two ways. First of all, firewalls are not good for internal attacks at all, because they sit at somewhere at the place that they look into the external traffic coming to the network. That is number one. Number two, even for the external, no one can says that I protect your system 100%. I can fully protect your system. That would be impossible. So this is incorrect, and this is the answer to this question. So let's go to free response one. Briefly explain why the concept of accuracy in biometric authentication makes sense. So in biometric authentication, we use some sort of biometric information to make sure that this is the user who has registered before. For example, we look at the fingerprint of that person, or we look at the iris of the eye of that person, or we look at the face of the person, or we look at or we monitor the pitch frequency or voice of that person. All of these things are subject to change. As a human, my face, I may look at the camera with this angle or a little bit tilted, like this. Or the light might be different. I'm the same person looking at the camera with the same angle, but the light is different. So the image captured by the camera is different. Or my voice, sometimes I do something like this and my voice looks different before and after that. Or my iris, for example, anything related to any biometric information related to human, they're subject to changes. Those changes for us as human are negligible, or our processing system neglects them. But for a computer decision-making system, those are not negligible. And sometimes those changes make the decision-making system not to be able to 100% identify if this was me or not. Because of that, because of all of these things that I said, biometric authentication always returns with a number, with a similarity metric, with a number that similarity or not metric or similarity score that always ranges between 0 to 1. 0 means that I'm 100% sure that this wasn't the person. 1 means that I'm 100% sure that this was the actual person. And these two never happen, 0 or 1, they barely happen. Most of the time, what you get is, for example, 95% similarity, or 90% similarity, or 85% similarity, or, for example, 30% similarity. 30% similarity means that there's a very low chance that this person is the actual person who is claiming to be. And that's why we talk about something called accuracy. How much this person, how many number of legit users our system is able to identify and authenticate accurately. So that is called accuracy. That's why it makes sense, because it unlike other authentication method, they don't rely on a yes/no answer. They rely on a similarity metric, and because of that, it makes sense that our system sometimes doesn't decide correctly. Okay, free response 2 asks about this chart. We have this chart, and it asks that the following probability curve for matching a score in biometric authentication was discussed. Briefly explain what would happen to the shaded area, which is here, if the authentication accuracy improves, and what would happen if the authentication accuracy degrades. Okay, this curve, if you look, it talks about the improper profile versus proper profile. and they have some overlap, meaning that there are situations that improper and proper they have overlap, and there is a chance for the system so that an unlegit, unauthenticated person is being classified or detected as authentic, and the system allows them in, or opposite. So if the accuracy improves, it means that these two overlapping curves, they should get farther from each other. Excuse. Excuse me. I had someone in my room. It was my boy. So yeah, I was telling that when the accuracy improves, the two curves, the overlapping curves, gets farther from each other, and you have fewer overlapping area. If the accuracy gets 100%, it means that there is no overlap between the two, and there is no way so that an unlegit user is being allowed to get access to the system, or vice versa. There is no way that an registered user is being denied. That is the time that accuracy is 100%. 95% is something like this, a little bit overlap. This is, for example, let's say 85%. There is a 15% chance of overlap, which means that there's a 15% chance that a registered user, a legit user, is being not allowed, as bypassed, ignored, or refused, which happens to you. I think if you have, for example, if you use your face recognition on your iPhone or your cell phone in order to get in, sometimes it's you, but it's not able to recognize you, and it doesn't allow you, and you have to enter the password manually. So that's why that thing happened. And what would happen if the accuracy decreases? If the accuracy decreases, the two curves gets closer, and the overlapping area becomes bigger and bigger, which means that instead of 15% chance, there is a 30% chance that the legit user is being not recognized, or an unlegit user is being approved and gets access to the system. So this is the answer. If the accuracy improves, two bell-shaped curves get farther and overlap less, or the area overlap becomes smaller. If the accuracy drops, the two bell-shaped curves get closer, and the overlap area becomes bigger and bigger. So, any question? So, and lastly, the third response asks about converting this matrix, converting this discretionary access control system represented in a linked list into its matrix equivalent. So this is the linked list representation. We have user A who has access to file 1 as read and write, access to file 3 as read and write. That's it. User B, though, have access to file 1 only as a read, file 2 read write, file 3 only write, file 4 only read. And user C has access to file 1 read write, file 2 read, file 4 read and write. Okay, we are asked to represent this as a matrix. We said that in that case, you can create a matrix like this, a table like this. Columns are resources or assets. File 1, file 2, file 3, file 4. Here we have file 1 to file 4. We have nothing more than these 4. And then we have 3 users, user A, B, C, that I called them here, 1, 2, 3. So user 1, file 1, we write it here. User 1, file 2, there is no user 1 or user A doesn't have access to file 2. So we put nothing here, which means, or we put null here, meaning that user 1 or user A shouldn't have access to file 2. User 1, file 3, owner. User 1, file 4, again, nothing. and so on and so forth. You can fill out this table. And you see here that the complexity is the number of files or resources or assets times the number of users. That's why complexity becomes OM times N. If you remember, we had this in one of the multiple choices, and I said that it should be multiplied, not divided. And it's very easy. And the reason we talked about, we started from matrix representation, and then we said that it can also be represented as a linked list. And the reason linked list is good, because look here, how many cells do you need? Here you need 4 times 3, 12 cells, regardless of who has access to what. If each user has only access to one resource, one file, you still need a 3x4 table. Or if all has access to everything, again, you need a 4x3 table. So the table, the size of that table, the memory that table needs is going to be always constant. But if you represent it as a linked list, that's not the case here. Here you only put those cells which are not null. Look here, this cell 2, and this cell 3. We have three cells which are null. That's why here, if you count 1, 2, 3, 4, 5, 6, 7, 8, 9, you have only, I'm sorry, 8, 9. We only have 9 basically cells here, and those 3 which are null are not represented here in the linked list format, which means that we save some memory. And of course, in a real situation, this table is getting huge. For example, you have tens, thousands of files, multiple different users and processes. So the actual size of a table like this, if you want to do discretionary access control, is going to be something in the range of, for example, 10,000 by 10,000, this big, or 10,000 by 1,000, which is very, very huge. And it makes sense if you can reduce that by any percent, 30%, 20%, which normally happens, easily happens if you represent it as a linked list. So the question asks just about the conversion from here to matrix to table. The question could have asked opposite. It gives you the table format and asks for the linked list format. But it's going to be very easy for you converting it, as long as you understand how does it work. So I think this was the last question, and I have no more things to add. If you have any question, please ask. Rad, I see that you have a question. Please go ahead.
Yeah, I'm just looking at the OMN. So that's the OMN. Basically, N is the number of users, correct? And the M is the number of resources.
Correct. Correct. M is one, N is the other one. You can assume M is the number of, this is a general case.
Yeah.
M is the number of users, N is the number of resources or assets, or vice versa. It doesn't matter, because you're here multiplying them.
So in this table, it will be 12, or it's going to be O of
That's
12.
a complexity. That's a complexity representation. You don't want to solve it. You just say OMN, meaning that 2 items are being. It's basically, I can say it's a binomial order 2. X square. I'm sorry. Instead of saying X square, I say OMN.
Okay.
It's only.
I'm sorry.
Yeah, go ahead.
I was just like this. You have like R times what's R? You know, is it there's values to have under that?
R? Did you ask about R?
No, I'm asking about in your writing the solution, OMN, and then you have the arrows going R times I don't know what's that.
Yeah, this is example I gave. I said, for example, you can assume in reality your N might be, for example, let's say 1 million different files in your computer and 100 users or processes. This was the example I gave, and I try to say that in reality the table gets very big. This is the number of resources versus the number of users. And M might be resources and N might be users, although you can swap him, it doesn't matter. But at the end of the day, the number of resources and the number of users are being multiplied. And if you have 1 million resources, which is a normal thing in a computer, and 100 different users or 100 different processes, because processes also might be seen as user. Don't say that my computer doesn't have 100 users, I'm the only user. Yes, correct. But you have many different processes. And each of those processes have different access. Was that clear?
Yes, thank you. I appreciate it.
Okay. Okay. So if there is no more question, we can probably wrap up here, and I'm gonna upload this on Blackboard so that others in the class can watch that and use that. And the exam will be available to you on Monday, 8 a.m. And it's only available by not the entire week. It's only available, let me quickly check. Because of the grade report deadline, I don't have the. So let me stop sharing and reshare my screen again, so that this is a very important, that your exam is gonna be available this is about the sample questions. Yeah, here, May 6th to May 9th. Only Monday to Thursday. So you don't have Friday. Please be aware that you, although you receive, I know that you receive notification about the deadlines of the things you have on Blackboard, but again, please consider this in your schedule, that you have from Monday the 6th to Thursday the 9th, 8 a.m. to 8 p.m. to answer the final exam. Okay, thank you, everybody. I wish you enjoyed this course. This is the last video that probably you're watching from me. You received a goodbye email, thank you email about taking this course sometime soon after I grade the final exam and compile the grades. But this is basically the last video you're watching from this course. Thank you and have a great rest of the day.